Today in this video we are going to discuss second order derivative test. So let's start. What is the second order derivative test to find maxima and minima of a function? So the second derivative test states that at maxima and minima both, the first derivative of a function that is dy upon dx, or we may say f dash x, is equal to 0, and at maxima the second derivative of the function d2y over dx square, or f double dash x, is negative less than 0, that is negative, and at minima d2y upon dx square, or f double dash x, is greater than 0, means positive, and if d2y upon dx square is equal to 0, then there is neither maxima nor minima. And at the point, so the point at which the first order derivative is 0 and second order derivative is negative is called maxima, and the point at which the first order derivative is 0 and second order derivative is positive, that is called minima, and the point at which the first derivative and second derivative both are 0, that is called point of inflection. So the point of inflection is a point at which a function has neither maxima nor minima. Now let us take an example. For example, we have taken this problem: find the maximum and the minimum value of the function fx is equal to 2x cubed minus 3x squared minus 12x plus 4. So what we have to do, as fx is equal to 2x cubed minus 3x squared minus 12x plus 4, let it be equation number 1. First we differentiate it with respect to x, so differentiating 1 with respect to x, we get f dash x is equal to 6x squared minus 6x minus 12. Let it be equation number 2. Then we find second derivative of the function, differentiating equation number 2 again with respect to x, we get f double x is equal to 12x minus 6. Let it be equation number 3. according to second order derivative test, at maxima and minima, first derivative of the function is always equal to 0. So it implies that putting the value of f dash x from equation number 2, we get 6x square minus 6x minus 12 is equal to 0. Now dividing both sides by 6, we get x square minus x minus 2 is equal to 0. Now we have to factorize this. So x square and minus x may be written as minus 2x plus x minus 2 as it is equal to 0. Here we have written minus x as minus 2x plus x in order to factorize it. Now out of the first two pairs we may take x common. Inside the bracket we get x minus 2. In the next one is common, so we get x minus 2 in the bracket is equal to 0. Now x minus 2 bracket is common, x minus 2, x plus 1 is equal to 0. So we have factorized the left hand side of the equation. So in that way, either x minus 2 is equal to 0 or x plus 1 is equal to 0, or x is equal to 2 or x is equal to minus 1. So we get x is equal to 2 and x is equal to minus 1, at which the first derivative of the function is 0. Now such points are called stationary point or critical points. Now we have to check at which point the function has its maxima and at which it has its minima. So for that purpose, we have to substitute the value of x obtained here one by one in equation number 3 to check whether the second derivative is positive or negative. So when x is equal to 2, f double dash x, as you see, f double dash x means the second order derivative is 12x minus 6. So substituting x is equal to 2 here, we have 24, because 12 2s are 24 minus 6, so we get 18. So obviously it is a positive number, so f dash x is positive. So according to second order derivative test, function has its minima at x is equal to 2. So x is equal to 2 is the minima of fx. So the minimum value of the function we obtain by substituting x is equal to 2 in the function. So we get 2 into 2 cube minus 3 into 2 square minus 12 into 2 plus 4. So we get 2 cube is 8, 8 2 is 16, minus 2 square is 4, 4 3 is 12, minus 12 2 is 24, plus 4. So 16 and 4 are positive, should be added, positive 20, and minus 12 and minus 24 both are negative, should be added. So we get 36. So 20 minus 36 is equal to minus 16. So minus 16 is the minimum value of the function which it attains at x is equal to 2. So x is equal to 2 is the minimum of the function and minus 16 is the minimum value. Now when x is equal to minus 1, when x is equal to minus 1. So let us check the value of f double dash x is 12 into minus 1, because f double dash x is equal to 12x minus 6. So putting x is equal to minus 1 here, we get 12 into minus 1 minus 12 and minus 6. Minus 12 minus 6 is equal to minus 18, which is obviously a negative number. So f double dash x is negative. So according to the second order derivative test, fx is equal to minus 1 is the maxima of the function, and the maximum value of the function is obtained by substituting x equal to minus 1 in the function. So we get 2 into minus 1 whole cube minus 3 minus 1 whole square minus 12 into minus 1 plus 4. So solving 2 minus 1 cube is minus 1, so we get minus 2. And here minus 1 square is plus 1, and plus 1 into minus 3 is minus 3, so minus 3. And here minus 1 and plus minus 12 becomes plus 12, so we get plus 12 and plus 4 as it is. So as you see, the 12 and 4 are positive, should be added, we get 16 positive, and minus 2 and minus 3 becomes minus 5. So 16 minus 5 is equal to 11.